Okay guys, welcome to this tutorial of while loops. It's tutorial series by Wayne Scientist. Okay, today we're going to look deep into the knowledge of while loops. Okay, what are while loops? These are simply repeating procedures that repeat certain functions until a certain condition is false. So if the condition is always true, the loop will keep on repeating. Just imagine when you write inside the while loop the block structure of the while loop. Let's say you say printf. The printf function will be called several times until the condition of the while loop is false. So in other words, it will keep printing until the condition is false. When you execute printf inside a while loop. So let's look in the next. Okay, this is a simple while loop. This is how we will declare our while loop. So first, in order to declare a while loop, to create a while loop, you have to start with the keyword while. After you write this keyword called while, remember it's case sensitive. So capital letter W and small letter w are different. These are all in small caps, so be careful. Okay, after you type in the while keyword, after that you need your brackets, and inside these brackets, that's where you write your conditions. What's a condition? Okay, you may ask. That's in the area we write the condition. What's a condition? You may ask. A condition is just like, there are some conditional expression we can use, just like greater than or equals to, or greater than or equals to. Okay, those are some examples of some conditions, and for this loop to run, the condition should be equals to 1. For this loop to open, like for the statements inside here to be executed, this condition should be 1, and if the condition is 1, the loop will open. Okay, I'll clear that. Okay, after you write your condition inside this bracket, remember you introduce a curly bracket and another closing curly bracket that will close the body of while loop. So inside this curly bracket is your body of the while loop, and this body is executed when this condition is 1. Now I clear on that, right? Okay, let's look. That's an example of a while loop. Remember, we start with our keyword while. After we start with our keyword, then braces, opening and closing, and inside those braces we write a conditional statement. In this case, it's 1. It's 1, right? And that will mean this open. That means this loop will open. Remember, the curly braces, they will indicate the body of while loop from starting here and ending to here. So while 1 means the loop will open, and what's inside will be executed. And in this case, printf is inside the while loop. See, from the starting brace, curly brace, to the closing curly brace, this statement is written within the body of while loop. So this statement is called So how many times that is this statement executed? Okay, let's do an example. This while loop repeats, like, okay, it starts when this condition is 1, the loop will open, right? After it will open, it will reach the first statement. Here the first statement is printf hello world. This will print hello world on the screen, and after it successfully print the hello world on screen, it goes to the last section. And if it goes to the last section, it goes back here. Oh, sorry. So it goes back here, and if the condition is 1, the loop will obey and it will reach this first statement. And after doing that, so it goes here and then goes back, and still the condition is still 1. So it will go then here, then goes there and returns back, and still the condition is still 1. So this will repeat infinite times. Like, it will not end. We just keep printing hello world, hello world, hello world, hello world, because this condition is always 1. That is always true. Now let's see. Okay, let's say you want to print hello world 10 times, or you want to print 5 times or 2 times. What we do, simply we can use the while loop and execute a condition. Okay, let's see in the next example what happened here. Okay, just let's do in steps. As you know, your program starts to the top, right? And this is all written inside the int main. Don't get confused. Yeah, written inside the int main function. If you don't know, just comment below. Okay, and the first line here we have int x is equals to 0, and this int x is equals to 0 declaration will assign the value of variable x with value 0. So currently in this line, x is assigned the value of 0. That, like, x is 0 is 0. Okay, after that we go to the next statement. This is a while loop. See, we start with the keyword while. Inside these braces we set a condition, and this condition is x less than 10. Okay, how does this go? X less than 10. What's the current value of x? The current value of x is 0. From here you can see it's 0, so it's simply replaced by 0 less than 10. And is 0 less than 10? 0 is really less than 10, so it's true. It will return true. That is, it will return 1. This statement over here is replaced by 1. And after that, if this is 1, that means the loop will open. Okay, as the loop opened, it will go to the first statement. Here this first statement is over here. That says printf hello world, and it will print hello world on the screen to us. And after it successfully do that, it will then move to the next line. That is the x plus plus. What happens here? The plus plus is simply adding 1 to the current value of x. It's like x here, current value of x is 0 from here, from this line. As we move to this line, x is incremented by 1. Remember, x then 0 plus 1 it's equals to 1. So that means x is now 1 in this line. As it goes to here, it then returns back here. Okay, here it's like x less than 10. What's the current value of x? The current value of x is 1, because from earlier we see x is being changed here from the last loop, right? So is 1 less than 10? 1 is truly less than 10, so it returns 1 as true, or true, that means 1. And if this is 1, then this loop will open. And then it goes to the first statement. After this, it's like the statement will print the hello world on the screen, right? After that, it goes to the next line. That is x plus plus. This will increment the current value of x by 1. Right? The current value for it from it is 1. Now from here it's been changed to 2. Now the value of x is now changed to 2. As it reaches here from the last, it goes back here. Stop. That's x less than 10. The current value of x here is 2 from the last loop, and 2 is really indeed less than 10, so it returns 1. After that, if it returns 1, then the loop will open. Then it prints this printf. It then print this hello world on screen, and if after it successfully do that, the current value of x from this line is then incremented by 1. That means from 2 is now equals to 3. So it goes here to this, and after that it goes back here. Now x less than 10, the current value is 3, and 3 is really indeed less than 10, so it returns 1 and the loop will open. So it will do that until it's false. Okay, let's say now we've run like 9 times. X is gonna equal to 9 over here from this line. Like it's now 9. It's now 9. Then x plus plus will change this current value of 9 to 10. And as it reaches the end of this, it then returns back here. And 10, the current value of x is 10, right? And 10 less than 10, is it true? This is false, because 10 is not less than 10, so it returns 0. After it returns 0, that means this loop is destroyed. It's now ignored, and statements below this loop are now executed. That's starting from the last. Anything down here you've written, maybe you've written printf. That's what's now being executed. Okay, now let's look for another example. Okay, this is a single countdown loop with while loops. It's now counting from 10. Let's see how it goes. First, we initialized the value of x to 10 because we want to count down starting from 10. You can assign any value. It's 20. You can count down from 20 for 1, or from 15, or any number you want to count down for. It's applicable. So now in this line the current value of x is 10. After that we move to the next line. This is the while loop. What simply does, we look in the expressions over here, then it says x should be greater than 0. That means the current value of x is 10, right? It's 10, and 10 greater than 0, it's true because 10 is really indeed greater than 0, so it returns 1. After it returns 1, this loop will open. This loop will open and printf is executed over here. And printf is like %d. This %d is replaced by an integer value that is over here, that's written over here, that is x. Yeah, it's like x, the current value of x, which is 10, right, is then it replaces this %d, and this /n is replaced by a new line. So it's like without the /n it would be like 10, 9, 8, but including this /n it would be like this 10, sorry, 10, 9, as you start in a new line, it will start in a new line. So that's the purpose of /n, that's /new line, that's n replacing the new line. Okay, so the current value goes to this %d, and /n will introduce new line in your screen, and after that it will print it will print 10, right, because the current value of x is currently 10. Then after that it goes to the next x minus here. Now x minus is like a decrement, it's a decrement operator that does the opposite of increment operator, the x plus plus we have been seeing it, we've been using earlier. So current value of 10 from this line is of x is 10 from this line, right? After this line x is decremented by 1, that means x is now 9 in this line, 9. And as it reaches over here, it then goes back here, just like we did there. That's true for all loops. And in this condition, x is 9. 9 greater than 0, it's true indeed, so it returns 1. So as it returns 1, this is true, that means this loop will open, and after it is successfully open, printf is called and %d is placed by current value of x. Here in this case current value of x is 9, so %d, the printf, it prints 9 on the screen, and this /n introduce a new line. So currently it's like 10 from the last print, and then 9 from this loop, 10 from the last loop, and then print the 9 is a result from this current loop we're looking this. That's what's printed on the screen. And after that it then goes to x minus minus. This is again a decrement operator, that means current value in this line is 9, and the x minus minus will reduce by 1, that means x value is now equal to 8. As it goes to the last here, it goes back in this condition again. Now x greater than 0, right? Yeah, the current value of x is 8 from the last loop, right? So 8 greater than 0 is true. This way it returns 1. As it returns 1, this loop will open and it will print the current value of 8. That's percent %d is replaced by x here. So it's now like 10 from the first loop, from the last loop, and 8 from the current loop. Is from the last loop, from the first loop, we see this from the last loop and this from the current loop, right? This is result from current, and you do this until this is true. Let's say until this is false, until this condition is false. Let's say x, let's say it did keep printing. Now so let's say x is now equal to 1 in this line. So it means this is already printed 1. This is already printed 1. And now in this line x is equals to 1. Then x minus what will happen? X minus will decrement the current value of x, which is 1, right? And this you like 1 minus 1 is positive to give us 0. And this 0 is now the current value of x. So as it reaches here, it then goes back here. And in this condition, it's like x greater than 0. Current value of x is 0. So 0 greater than 0 is 0 greater than 0. It's false. 0 is not greater than 0. It's equal to 0, not greater than 0. So it returns 0 because it's false. As it returns 0, this is cancelled. This is not open. It's just like it's destroyed. It's not destroyed, and the result you print 10. It's like 10, 9, and it will print up to 1 from the skin in a new line like this: 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And why 0 is not printed? Because 0 is not greater than 0. So when the value of x is 0, this loop is destroyed. That means it is not allowed to enter in order to print that 0. It's not allowed to do that. Okay, let's see. Okay, we're done. Okay, welcome guys. On this, I want to show you example on the application of while loops. In this, we are going to do a while loop application that like a timetable. It's like timetable for 2 is 2, 4, 6, 10, right? And timetable for 5 is 5, 10, 15, 20. That's exactly what we want to do using while loops. So in this, we want to do a timetable of let me see my favorite, 9. We want to do a timetable for 9. So the first statement is to include include std.io.h. Why do I need this? Because I need to print on the screen. Okay, if you want to see what's in the contents of std.io, just click Control on your keyboard, then click on this file, and you can see inside this file. That's where it's already written for us like this. Okay, I'm gonna try this. Okay, do you remember put C, and put char, and puts? We can use that. Those are already written in this. Okay. Okay, remember, will you scan F that's already written here. And remember, we use printf here. This like it's already written over here. That's printf here written. That's how we use this printf inside. Okay, and that's okay. Now we have to declare the body where we can start our program. That's int main. Sorry, be careful of some spellings. Now this is our function of int main. Okay, we have to algorithmize in order to do what we want to do, to make a turntable. You see, like, okay, in this we need the value that will change in every loop. So in case it's 9, it will be 9, 18, 20, 76. That means it's an integer value because we are only holding whole numbers. So I can declare int like I will can read time is equals to 0. I just retain time. Okay, doesn't matter. Okay, I just assign the value of time currently to 0 because we want to start from 0, 9, 18, 20, 36, 45. Okay, now we have to declare the while loop that will increment every time. That's while. Okay, inside that's where we will write our condition. So what do we want to write? Say it's 0, 9, 18, 27. We want to write a timetable of 9, so we want to end somewhere 90. Let's say 90. So while time less than 90. Okay, this is wrong. Why I say it wrong? Because when time is equals to 90, then 90 less than 90 will give a false. That means 90 is not printed, and we want to print 90. So we insert this greater than equal sign. It means when time is equals to 90, this loop will open and prints 90. Okay, now we have to. These are now the body, like from starting and ending of the loop. Okay, now that's where we want to write the. Okay, how can we do that? Okay, you have to declare a printf first of all. Okay, I want to make like a modern timetable, like 1 times 9 is 0 times 9, 1 times 9. So currently I want to declare another variable. Why? You can see the magic layer. I can just create x and say 0 because I want to do like 0 times 9 equals 1 times 9 equals 2 times 9 equals like that. Okay, then we have to printf like from the stdio to h. That is %d. This is gonna be replaced. This is gonna be replaced by the first integer out there. We have declared outside the double quotes. Then we have to say times. So there's no times in the keyboard. Good. %d times 9. Then equals %d. This is replaced by the first integer declared outside double quotes, and this is gonna be replaced by the second. So if I say bracket x, this x will replace the first %d, then comma time, then close. Then this time is gonna replace this %d, this and this links together. This one and this one, they link together, and this one they link. It's like currently x is equals to 0, you know. So it's like 0 from here, 0 times 9 equals to %d. Currently time is equals to 0. We know that. So it's like 0 times 9 equals 0. It's a good timetable. Now we have to introduce this. Why we introduce it? Because we want to make it like in an order way. just in listing those timetable instead of doing just in one line. So we want to do it. Okay, after that I say x plus plus. Why x plus plus? Because in the next loop x will be equal to 1, and like 1 times 9 equals current value of time. Then I'll say time plus equals to 9. What's happened there? It's like it's just similar to time is equals to time plus 9. It's just same because you can add the current value of time. In this case is 0 plus 9. You'll be equal to 9. So yes, make this and equals 9. That's the programming way of doing that. Now time plus is equals to 9. That means you will add the current value of time with 9. So in this case it's 0 in the first loop. It's 0, that's 0 plus 9 is equals to 9. So time in the next loop, time less than or equal to 90, that means 9 less than or equal to 90. Currently the time value is 9. So this is true because 9 is really less than or equals to 90. It's less than 90, so it's true. Then in this line it will print. In this line it will print current value of 9, current value of x, that is 1 from the last loop, because it included 1 from the last loop. It's like 1 times 9 is equals to current value of time, which is 9 from the last loop. So it's 1 times 9 is equals to 9. See, cool. In this loop x is incremented by 1 again. That means x is now equals to 2. And in this line time is incremented by 9. That means current value of 9 plus 9 equals to 18. Now currently time is equals to 18. So as it goes here, it then goes back here. Still 18 is less than 90, so it will open. And here currently from the last loop, %d is replaced by the first one over here, that is 2 times 9 is equals to %d, that is time, the second one, which is 18 from the last loop. That's 2 times 9 is equals to 18. See, it's now working. And outside this loop we just say return 0. Remember, this is outside the line. This is outside this loop. This is not in this loop. It's in this main function because we declared int over here. Okay, if you don't want that, you just remove this and then remove this line also. But if you want that, declare and then return 0. If you want this chart, if you want like double, and return 01. That's only okay. We just leave it like that. Just we have to print. Now I have to execute and compile and run and save the file to. I don't know if we'll time and save. And now it's compiling. Then check what happened. You see, it's magic, right? Okay, that's it for now, and I think you've now understood the concept. Thank you.